Okay, good afternoon, everyone. I hope you had a coffee and your lunch and everything. And this is going to be hopefully a stimulating presentation to brief you on automated binary vulnerability analysis. I'm super excited to be here with you this afternoon. Before I get into the kind of technical weeds, I wanted to kind of start with the backdrop of the 2026 acquisition reality. It's really about field faster and prove risk. Right? So what that means is mission capability is increasingly software defined, platforms, comms, C2, mission apps, etc. At the same time, there's zero trust. Everyone keeps talking about zero trust. There is cyber supply chain risk management, etc. These are all must-have in program oversight, right? At the same time, ATO timelines can't dominate schedules anymore. There's a push towards continuous evidence. Continuous ATO is a thing, right? And naturally, adversaries prioritize what's exploitable. So there are KEFs, which is known exploited vulnerabilities, and 0 days that people know about. So there is definitely an increased skill level on the attacker side. Program officers really have to ask themselves the question, can we show defensible cyber evidence for what we actually field? That's sort of the 30,000-foot acquisition reality where this binary vulnerability analysis fits in. Here's a quick slide about object security. So we provide precision vulnerability validation for defense and critical infrastructure. We're quite heavily DoD funded through the SBIR R&D program. We've commercialized products out of that, and some of them are fielded in the Navy and elsewhere. There are 5 focus areas that we focus on as a company currently. So binary vulnerability analysis is one. It's our flagship product, BinLens. It's fielded in the Navy and other places. We also do AI ML trust analysis. We have our product called 40-layer that we will be presenting an innovation spotlight at 3:40 this afternoon. Zero trust access policy automation. There's some R&D, advanced R&D that we're doing. Same with 5G SATCOM vulnerability analysis. It's between somewhere TRL 5 and 6, and supply chain risk analysis 2. We can be procured through Platform 1, Tradewinds, SBIR, Phase 3, and partners like Carasoft. You can also find us at the Carasoft booth later if you miss us here. Yeah, that's about the company. Let's talk about the evidence gap in vulnerability analysis. So most delivered capability today includes opaque vendor software, right? So that's a problem where binaries get delivered or firmware gets delivered, appliances, embedded components, etc. And an SBOM is often not as good as you'd like it to be, or it's not even delivered, right? Traditional scanning answers what hypothetical vulnerabilities exist. So for example, if you run a static analyzer over a software, it will find every possible, 5,000 possible vulnerabilities that might be true or not, right? But really, these tools, almost none of the tools can answer what's exploitable here in this binary, in this configuration, right? So validation is the missing leg in this big picture acquisition question, right? Proof of exploitability and reachability of the artifacts we actually field. And that's sort of the big picture, call it program office level backdrop. Getting more into the technology side. So why the tooling that we have today is insufficient, so it's sufficient but not enough, is because there's often opaque binaries and firmware where there's no source code or limited endpoint agents, etc. So you can't collect enough information, you don't know enough, right? There's an on-prem reality. Most commercial tools out there are SaaS, if it's civilian, and that doesn't work for the Navy for many reasons. There's a lot of CVE noise, like 200,000 CVEs, and just because you have that somewhere doesn't mean it's necessarily exploitable. Also, CVEs mean it's already a known published vulnerability and not an unknown, unpublished one that you discover. So it's kind of, if you will, a good step to search those, but these kind of SBOM tools, etc., they're not sufficient, right? Manual validation, so that's red teaming. The red team test labs do that. That just doesn't scale. They're doing a good job, but it doesn't scale. And our customer base is, in fact, those red teamers. So BinLens is about closing that evidence gap. It provides deterministic binary level validation that produces audible evidence for prioritization, acquisition risk decisions, and ATO evidence, right? So essentially, it's like a human reverse engineer in a red team lab, but automated. Here's a picture that kind of signifies all of this. So we have this policy and threat pressure. Program offices have that today. So things like zero trust, supply chain risk management, CATO, et cetera, like I mentioned. At the same time, we got this threat pressure that it's easier and easier for attackers to find the holes in your software, right? So that evidence gap is real. At the same time, you got these opaque binaries, firmware, et cetera, and a lot of noise in the tools. So BinLens helps you to find what's actually exploitable in what you field. So it provides decision-ready outputs like validated exploit paths using something called symbolic execution. And I will show you a demo, right? Prioritized fixes, auditable reports, etc. So let's deep dive a little, and there will be formulas and other good deep dives, so stay tuned. I'll come to that in a sec. But for now, here, a bullet list of the main features. So it is designed to be fully automated. So it's different from like getting a random open source tool and driving that as a reverse engineer. It's got high accuracy and minimal false positives compared to alternative approaches like the typical SAS scanners or signature lookups, etc. I say right now it also is a lot slower than those as a result because it does some pretty substantial heavy lifting. And the heavy lifting, the thing that sets us apart, the feature set that sets us apart from other vendors is symbolic execution. That's like fuzzing, but instead of fuzzing where you go through every possible combination of parameters to see what blows up, you drive mathematical formulas through the control flow graph of a binary to see what can happen, what can't happen. And I have an example explanation for you coming up on the next slide. What it does, same as fuzzers, is it provides inputs to reproduce the vulnerabilities. That's a real big deal. So we'll literally say if you run this binary with these inputs, this buffer overflow at this location will happen, right? Because it starts from scratch with a binary versus just doing a lookup, it identifies unpublished potential zero-day vulnerabilities. That's why we're usually only deployed air-gapped, even though we provide a SaaS offering also, because you don't know what you're going to get, and it might be that zero-day that you don't want anyone to know about. It also means it can analyze unpublished, proprietary, and classified software. That's what it's used for, because it's not based on an external threat feed or an SBOM feed of public open source components, etc. It has pretty broad analysis support, including IT and to a lesser degree OT and ICS. I can get into this in a Q&A or afterwards. This is not as simple as this bullet may seem. But very important, on-prem, offline, air-gapped. This is a really important feature set for the Navy because, well, these things run essentially completely air-gapped in red team labs or in a DevSecOps chain. Here's kind of a picture. We'll have a demo later, but here you can see in the middle, so you see a Stack Overflow in the interface. You can see inputs to reproduce. It tells you that, and it shows also function call stack, basic blocks. There's more like decompile, disassembly, etc. So it gives a red team really a good amount of information. All right, so I've been tossing this symbolic execution term around. This is the deep dive slide, so bear with me if you if it's too much, just hold out for like a minute. But there's going to be some math there. I'm not the math guy, but I hope I can explain it. So symbolic execution executes programs or simulates programs, if you will, with symbolic inputs representing multiple values. So think of variables, right? And then it tracks how runtime behavior evolves throughout the program. So the scientific concepts are things like constraint solving, ASTs, static analysis, etc. So this is the difference between a static scanner and something like symbolic, is that symbolic will check whether there is a path, an exploitable path towards a vulnerability, versus a static scanner will just look if a specific isolated operation or set of operations could be, for example, a buffer overflow. And you'll see that in a sec on the right side of the slide coming up. But either way, so it analyzes program states to identify vulnerabilities, undefined behaviors, and memory safety violations. Here is the math. So what you can see, and my eyesight's not that great, but what you see is a bit of C code. It's pretty simple. There's basically an input that we read at the beginning called X. So somebody enters X basically into this function, and then Y says X is X plus 1. So if we assign a symbol, which we just call alpha here, to X, say X is alpha, and we don't know what it is. It could be anything, like say an integer or something like that, right? So it's got 65,000 possible options. It kind of doesn't matter at this point, but if we say Y is then alpha plus 1, and Z, because Z is Y plus times 4, Z would then be obviously the alpha line there. So Z is 4 times alpha plus 1, right? Now the interesting part is where the if condition comes, right? So on the if, we say if the Z is greater or equal than 20, we go into this function, right? So you can see if you already know what Z can be. Z is, in terms of alpha, it's 4 times alpha plus 1. If that's greater or equal than 20, then the alpha is greater or equal than 4, right? So that's here, right? So what that tells you here is anything that's at least 4 will go into this subfunction, right? Now I also have a 16 in the line underneath, a buffer with 16 characters, and I'm writing a bit further down like a larger number, which is the Z, into the 16-byte buffer. That's where the buffer overflow is, right? So if I write 17 characters into a 16-character buffer, I have a buffer overflow, right? So here I can then deduce all the numbers that I just put in from the alpha and realize, well, if it's 4 times alpha plus 1, because that's what the Z was and the Y and so on, if that's greater than 16, well, then I have the buffer overflow. And then I can say, well, I just divided by 4. So alpha plus 1, if that's greater than 4, I got the buffer overflow. So alpha greater than 4, it's the same thing, meaning just anything, the X, anything greater or equal than 4 will basically provide a buffer overflow in this, right? Now I did one constraint solving instead of trying 65,000 values, which I don't know, I mean, when you would have started, and the fuzzer would have gone through all of these combinations. That's what fuzzers do. Here you only have one formula. That's the beauty of symbolic execution. It's been around in the scientific community for a while, but there hasn't really been a vendor being able to build that in an automated way that actually works. So that's kind of what we do. So here's how BinLens works before we go into the demo. That's actually much simpler than it looks. Basically on the left, you just dump the binaries into the tool. That's the left arrow here. And it could be anything from individual binaries to packed images to a bunch of ISAs like processor architectures and operating systems and image formats, etc. It will basically unpack those and analyze them. So like I said, disassemble, decompile, run the symbolic analysis on the binary, do some source code analysis, do some crypto analysis, a bunch of stuff, right? And it produces proofs of vulnerabilities and a report, multiple reports. It has API capabilities. And the grayed out pieces there, AI remediation and the GPUs, they are in the upcoming release 4.0, where we have a whole LLM-based other feature set on top that's very powerful. I'd love to talk about that later, and I'll show you a demo of that too. The whole thing can be installed on a cluster for speed because it is very performance intensive. Here's some of the things we find. I won't go through all of them, but it's things like stack overflows, heap overflows, etc., weak pointers, crypt, and then also static things like finding certain CWEs, and we have a CVE feature too, so we do find published vulnerabilities too with an offline feed, so you don't have to go to the NVD. Target user groups, just to wrap up before the demo. Red teams, reverse engineers, vulnerability research is the top one. The Navy just bought a 5-year license for their red team. This is the significant target group because they're already doing this, but they're doing it manually and it takes weeks, and this brings it down to hours, right? Second one, we have DITRA as a current customer. That's the nuclear security guys. It's in the DevSecOps pipeline, so DevSecOps engineers, product security, QA, and developers. This is research under SBIR that's supposed to be fielded later this year. So it would be towards the tail end of DevSecOps for release engineering. And then operators and buyers also they can scan stuff before they field. And like I mentioned, we're awardable in multiple schemes like TradeWinds, Platform One Marketplace, SBIR Phase 3, and also through partners such as Carasoft. All right, so here's a demo. I'll run that. It hopefully, yeah. So now you can see a bunch of stuff here. This is the product here. So there's basically on the symbolic execution tab, there's really no noise. You only have very few results because they have to be kind of exploitable in order for it to trigger. There's also common mitigations that it will tell you based on best practice. It will tell you the inputs to reproduce. That is really a key piece that's different from most other approaches. So you can prove it thanks to the symbolic execution. You can just verify, is this a false positive or not, by executing your binary with the offending inputs, so to say. It shows you the related CWEs, maps also to compliance, by the way. We have multiple compliance mappings. It shows you decompile, disassemble, vex, etc. This is not source code. This is decompiled, so you have to kind of, the developer has to do a little bit of translation there, because yeah, we usually don't have the source code. It shows the function call stack, basic block path, all these things that for reverse engineers mean a lot, all in one place. Very helpful for just speeding things up, right? So let's look at a second demo for the upcoming version 4. Version 3 doesn't have this in, but this is a chatbot-based approach. It is already working, as you see, it's just not baked into the current version. So you can basically analyze your binary by talking to our product like you would talk to ChatGPT. When you do that and you drop your binary or you point it to your GitHub or GitLab branch or whatever it is, it will live scan everything and live show you directly the results as it's unpacking, looking at things and analyzing. That's much broader than the non-AI version because it supports a lot more like programming languages and things like that, and finds potentially stuff that we haven't even considered. Now, this isn't just running an LLM over the binaries. It's using all the information that I've shown you already in the previous demo, to get there. Otherwise, it would have never be able to do this. It also explains everything. So that's key. It's not just going to say, here it is, but you can drill down and say, where is it? Why is it that case, right? Why? And then actionable insights, it will tell you how to fix it. It will produce essentially the instructions for a patch. So that's pretty exciting. We can have that as select customers get that as a preview already. Yeah, I think that's that on the upcoming what's in the future in our product. Like I said, it's going to be end of Q2. So in conclusion, there's the need that programs must field faster while proving cyber risk against KEF and zero-day realities, right? So the threat landscape has changed. At the same time, these major initiatives across the Navy, like Zero Trust and Scrum, they demand that basically. So there's a need to do better. The gap at the same time is opaque binaries and the constraints of on-prem and the air gap, that just means there's not that many tools out there. And the things that the government's been pushing very broadly, like SBOM, while they're like a nice kind of, if you will, baseline, it really doesn't answer the question, is this exploitable here? Because you don't know, you only know what's already published and what's already in the field, and patches are out there, and the NVD sometimes lags like 2 years or something. So BinLens bridges that gap, closes that gap through deterministic binary level validation that outputs auditable evidence. So what's exploitable and what to fix first. And that's for prioritization, for reducing or measuring acquisition risk, and for ATO, especially CATO. If you have continuous ATO, you would need to scan things all the time, right, when it comes in. So I would suggest, just as what would you do if you want to get this started, pick 1 or 2 target binaries or firmware and the decisions you need to make, and then run a short on-prem pilot and scale then to towards release and sustainment. So we provide free trials. It's very easy to use. If anyone wants a virtual appliance, for example, we just provide a virtual appliance that you can install in an air-gapped environment. There's no ATO concerns. You just have a box somewhere, you run it, you scan offline, and there's also Navy track records, so you're not the first one that needs to explain why this is happening, right? So with that, I'm through everything that I have. Visit us at the Carasoft demo pavilion today. 3:40, we're going to talk about our AI product 40 layer. And I don't know if I have time for questions. Nope, no time for questions, but I'll be out on the side here and hopefully meet you guys all there. Thank you very much.